Hey guys, what's happening? All right, moving on, completing the square. Now this is one extra technique that you can use when solving equations, okay? And I'll show you how to do that. Right now the technique that you use is either factoring when it's set equal to 0 or taking the square root of both sides, okay? So what we're going to do today is another technique that you can use. It's called completing the square. I'm not going to do it the way I do it in class. If you want to see a cool visual, it's in the book, okay? So take a look at the pages that I give you, okay? But right now I'm just going to show you just the straightforward way how to do it, okay? And you may have even seen this before. All right, so here's my first example. I have x squared plus 12x plus c, okay? What you do to find c is you're going to take the 12, the b term, right? The a term is 1, the b term is 12, and the c term, we're going to find that out, okay? To find c, to make this a perfect square, okay, is you're going to take the 12, you're going to divide it by 2, and then you're going to square it, okay? So, b divided by 2 squared is going to give us c, okay? That equals c. All right, so let's try it. We get 12 divided by 2, that's 6. Square it, that's 36. Okay, so 12 divided by 2 squared equals 36. So c equals 36. All right, so now we get this. We get x squared plus 12x plus 36, okay? It says find c, and then write the expression as the square of a binomial, okay? So now what we have is a perfect square trinomial, okay? So all you have to do is this, okay? Now, I'm gonna do it the long way, and then I'm gonna show you the short, easy way, okay? Check it out. What goes here and here, this times this gives you this. The only reason I'm doing it this way is just for more practice, okay? This times this. Sorry, I'm getting weird messages on my phone. iPhone is not activated. Okay. All right, so x times x. All right, this times this gives me 36. Well, 6 times 6, okay, 6x. X times 6 is 6x. I add them together and I get 12x, right? So plus and plus, all right. Notice it's x plus 6 and x plus 6. Well, that's x plus 6 squared, okay? That's how we write the expression as the square of a binomial. All right, but I'm going to show you the shortcut. Check it out. X squared plus 12x plus 36. What do we get if we just cut the 12 in half? We get 6. So watch this. The shortcut is this. We know it's going to factor into a binomial squared, and all you have to do is put x, and then whatever this is, cut in half, plus 6, and we're done. Okay, that matches this. Okay, but if you forget that little trick, you can always factor it. Let's try another one. All right, we have x squared minus 13x plus c. Now I did this one on purpose because 13 doesn't cut in half evenly, right? Okay, so we'll do this. Ready? We're going to go 13 divided by 2, right? Square that. What does that equal? Well, 13 squared, what is that, 169? Okay, 169 divided by 2 squared, that's 4. Okay, and that's my c term. Okay, so there's c. c is 169 over 4. And if I wanted to write that as a trinomial, okay, that's x squared minus 13x plus 169 over 4. Okay, that's cool. That's my trinomial. And now let's factor this. Ready? We're going to factor. It's going to look just like this. It's a binomial squared, right? I know this looks insane, but it's not. Watch. Since we found this, right? Since we found this value of c, then automatically this becomes a perfect square trinomial. Okay? And because it's a perfect square trinomial, it's just going to factor like this. A binomial squared. What goes here automatically? X, okay? What goes here? It's this guy cut in half. So minus 13 over 2. And we're done. Okay? All right. So that's the that's the basic idea. Now there's some really cool math behind it. In the picture, there's a picture, a really cool completing the square diagram in the pages that I've attached to the notes. Check it out, it's pretty cool, all right, if you have spare time and an interest. All right, here we go, let's do some more. All right. Part B, complete the square to solve. Okay, and just a note, A has to equal 1. Okay, A has to equal 1. All right, so let's do one. Example, x squared plus 6x minus 3 equals 0. Okay, take a look. What is A? A is 1. Okay, that's wonderful. Since A is 1, we're in good shape. Here we go. Since A is 1, and I didn't mention it over here. A is 1, A is 1. You notice that? A is 1 in both cases. We're good to go. All right, so since A is 1, we can go ahead and complete the square. All right, so cut that guy in half and square it. Okay, that's what we're going to do. All right, but let's take this 3, move it over to the other side. So we get x squared plus 6x. Leave some space right there, equals 3. If I move that 3 to the other side, it becomes positive 3. Okay? All right, so now take the b term, cut it in half. 6 divided by 2, that's 3. Square it, that's 9. So I'm going to add 9 right there. That's my value of c. That makes this a perfect square binomial. Trinomial, sorry. Okay? Since I added 9 to this side, I also have to add 9 to this side. And I get, ready for this? This factors into x plus 6 divided by 2 is 3, okay? And that equals 3 plus 9 is 12. Okay? All right, now take the square root of both sides. Okay. Don't forget your plus and minus, all right? Square root of that becomes x plus 3 equals plus or minus the square root of 12. I'm just going to do this quickly. That's the square root of 4 times the square root of 3. The square root of 4 is 2. So plus or minus 2 square root of 3. Now subtract 3 to the other side. X equals negative 3 because I subtracted it to the other side. Then we still have the plus or minus 2 radical 3. All right. Let's do another one. I think I have room right here. Oh gosh, I hope so. All right, now I'm going to go 7x squared plus 28x plus 56 equals 0. Okay? What does A have to be? A has to be 1. Okay? A is 7. Okay? So what you're going to do is divide everything by 7. Okay? So divide everything by 7. Watch this. That divided by 7 is x squared. Okay? This divided by 7 is plus 4x. Okay? This divided by 7 is 8. So plus 8 equals, that divided by 7 is still 0. Did you catch that? Okay, so now we have the exact same expression. Okay, we just divided both sides by 7. We divided everything by 7, right? Everything by 7. See that? Okay, and now we have this expression. It's exactly the same as the one above it, but it's nice. Now look, A is 1. So move the 8 to the other side. Here we go, x squared plus 4x. Leave a little bit of space equals negative 8. Okay. Now, complete the square right here. So cut that in half, you get 2. Square it, you get 4. So plus 4. If I added 4 to this side, I have to add 4 to this side to keep everything balanced. All right. Now I've added I've completed the square. So this is now a perfect square trinomial. So it factors as a binomial squared. That's x. Cut that in half, you get plus 2. Okay, x plus 2 equals, and now negative 8 plus 4 is negative 4. All right, now we'll take the square root on both sides. Don't forget, there's a plus and minus right there. Okay, if I square root this, it becomes x plus 2 equals plus or minus, right? Okay, plus or minus, I have 2 answers. The negative inside the radical tells me I have an imaginary answer, and the square root of 4 is just 2. So the square root of 4 is 2, but it is imaginary, so it's a 2i. So I have two answers, positive 2i and minus 2i. Now all I have to do is move that guy over to the other side. So shift it over to the other side. We get x equals, if I move this over, it becomes negative 2. And then I still am adding it and subtracting it, or adding and subtracting a 2i from that. All right, that's the gist of how those problems go. Now let's do one last little bit, part C. Okay, we're going to write in vertex form and state the vertex, okay? Write in vertex form and state the vertex. And I'm going to try to keep this in, oh boy, in 4 minutes. Okay, here we go. Example, I'm going to do this really fast, okay? X squared minus 4x minus 1. Okay, this is how we do it. Okay, I'm going to move that 1 over. So x squared minus 4x, just move it over. Okay, all I did was shift it and put a little space there. Complete the square right here. Cut it in half, you get negative 2. Square it, you get positive 4. So I'm going to add 4 right there. Since I added 4 to this, the only way to keep it the same is by subtracting 4 at the same time. So I'm going to subtract 4, okay? All right, and now watch this. This becomes a perfect square trinomial. So it factors like this, and you get, cut that in half, it's negative 2, so this is x minus 2, okay? And then negative 1 and negative 4 is negative 5, okay? That's done. We've written this in vertex form, and now watch this. We can state the vertex. The vertex, since we're in vertex form, I'm sorry, you know what? This should have said y equals at the start of it. I don't know why it didn't. I apologize for that. Sorry about that. Example. It should say y equals, okay? So this says y equals, my bad, okay? And now that it's in, that was really weird. Sorry about that, but I'm not going to start over. Y equals, here's my vertex, right? My vertex is going to be opposite, right? H opposite, so 2. And k, keep it the same, negative 5. All right, let's do one more. All right, so we have y equals, I don't know why I didn't say that. I wonder if your book says that. Yeah, it says it. That was weird. Okay, my bad. Y equals 5x squared, okay, plus 10x plus 7. All right, last problem, here we go. The a has to equal 1, okay, but the a does not equal 1. So what I'm going to do is just concentrate on these guys right here, okay? Leave that 7 over to the side. Watch this. Y equals, okay, I'm going to factor out the 5 from both of these terms. So 5, I get x squared plus 2x, okay? And I'm going to leave that space right there, okay? I'm going to make a trinomial, okay? All the problems work out exactly the same, and then the plus 7 goes out here. Okay, so now, cut the 2 in half, you get 1. Square it, you still get 1, so I'm going to add 1, okay? Now, over here, when I added the 4, I subtracted the 4, right? Over here, I added the 1, so you might be thinking, okay, so subtract a 1. But this is the special case. If I add a 1 inside these parentheses, I didn't really add 1 because it's being multiplied to a 5. So by putting a 1 in here, I've really added a 5 to it, okay? Since I added a 5 to this, the only way to keep it the same is by subtracting a 5. Okay, did you catch that? All right, and now check it out. Check it out. We have y equals 5 parentheses, something squared. This is a perfect square trinomial, so now it's just x, cut that in half, you get plus 1, okay? And then 7 minus 5 is 2, so plus 2. And here's the vertex. Opposite, negative 1. K, keep it the same, so H opposite, K, keep it the same is 2. And that's that, okay? All right, guys, good luck.